So for this particular problem, well, actually both of the ones, number 13 and 14 here that we're working with, we need to keep in mind what we learned earlier in class, which is the product of a number and its reciprocal is always equal to 1. So, product of a number and its reciprocal is always equal to 1. That's going to make doing these problems pretty easy. We got, we have negative 8/9, x equals 5/6. Okay, and what we can do is we multiply by the reciprocal, which is 9/8, and we do that here. We also need to do that same thing on the right-hand side of the equation. That's the property of equality. But the property, or I'm sorry, the idea that multiplying a fraction times its reciprocal will give us 1 is going to allow us to clear that fraction out and away from our variable. Proof here would be that, negative times negative. This negative 9/8 times negative 8/9 would be 72/72, which is 1. And 1 times x is x. So this is taken care of using that idea of multiplying by reciprocals. On the right-hand side of the equation, we have two fractions being multiplied together. We can reduce a little ahead of time. The 6 and the 9 both share the common factor 3. Divide 6 by 3, you get 2. Divide 9 by 3, you get 3. And it's still negative. And nothing else can be reduced here. The 5 and the 8. Nothing between the 3, 8, 5, and the 2. So go ahead and multiply straight across. 5 times 3 is 15. 2 times 8 is 16. We had a positive times a negative fraction. Positive times negative is negative 15/16. On problem number 14, same sort of equation and way to go about solving it. We have to, again, convert this mixed number to an improper. 2 times 4 is 8, plus 1 is 9. Keep your denominator fourths. It was negative in its mixed number form. It'll be negative in its improper form. We have a k there. On this side, we have 3/12. You can multiply now by its reciprocal, 4/9, negative. Whatever we do to one side, we need to do to the other. So we'll also multiply it by negative 4/9 on the right-hand side. On the left side, over this side, you end up with 1. And 1 times k is k. So basically, we take care of the fractions. We get the variable by itself, which is always our goal. On the right-hand side, we're multiplying. We can do a little reducing ahead of time. The 3 and the 9 share a factor of 3. 3 divided by 3 is 1. 9 divided by 3 is 3. The 12 and that 4 share a factor of 4. 12 divided by 4 is 3. 4 divided by 4 is 1. And this just saves us a lot of time. We don't have to do any reducing afterwards. 1 times 1 is 1 for the numerators. 3 times 3 is 9 in the denominators. And we did have a positive fraction times a negative fraction, so it's a negative 1/9. We have to be very careful to double check our signs before we call it quits in a problem. For anyone who doesn't like reducing ahead of time, you could just, where's my highlighter? You could multiply straight across here. You would end up having 3 times negative 4 is negative 12. 12 times 9, 108. And we had a positive times a negative, so negative 12 over 108. Then you would have to start reducing. Some people would probably try 2. You'd end up with negative 6 over 54. And at that point, somebody might catch that you can divide them both by 6. And if you divide both these, well, we're running out of room. Divide them both by 6. You'll end up right back here where we got to in one step by simplifying ahead of time. And it can be done either way.